Morning, guys. I promised to show you how to quickly find the sines and cosines of the reference angles. So ke batla re qale hanyane ka unit circle le reference triangles. Jwale le tla hopola from algebra hore we have these two reference triangles whose ratios stay the same. So for this one, we'll always have pi over 6, pi over 3, and 90 degrees, which is pi over 2. If we have this, it is here, this side will always be square root 3, and this one will always be 1, and this hypotenuse will always be 2. So you're going to refer to this triangle and also this one to solve this basic angles dealing pi over 3, pi over 6, and pi over 4, maybe as well as pi over 2. Right, so re hopole he hore ena ya 45 degrees kapa pi over 4, e tla dula ena le 1 square root 2. So going back to our unit circle, re tla hopola hore for the unit circle, the way we label our angles, re qala from this would be our initial site. So let me use a different color. Okay, so now we have let me write here 0 radians. Okay, and as we go anti-clockwise, where we have 90 degrees, which is pi over 2, we have pi radians, and then from here that way we have 3 pi over 2 radians, and we complete a revolution with 2 pi. And we said earlier that okay, now that we have these angles, let us, because remember this is a unit circle and we have a center here at 0, 0, and this says to us that the distance from the center to the circumference is 1. The radius will always be 1. That should be noted. Right, so let us label these intercepts here, the 4 intercepts. Okay, we have 1, 0, and here we have 0, 1, and here negative 1, 0, and 0, negative 1. We remember that when you have the coordinates x, y, then x resembles the cosine of some angle and y represents the sine of some angle. This we did trigonometry in algebra. Right, so now it's easy for us to evaluate angles, I mean cosine and sine of this angles here, using the unit circle. So this says to us that the cosine, the cosine of 0 radians, cosine is x. So the cosine of 0 radians is 1, and the sine of 0 is 0. Right? The same goes to for 2 pi. Let us do the next one. Okay, we said that this is the x, this is the y. X is cosine, y is sine. So the cosine of pi over 2 is 0. The sine, which is the y value, the sine of pi over 2 is 1. Coming here, the cosine of pi is negative 1. The sine of pi is 0. And then lastly, the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is negative 1. right? Okay, now that we understand this, re tlo tla re tswela pele and integrate re kenyeletse all these angles in the unit circle. Remember that in this case, our radius is 1. So let us first include the small angle, pi over 6 in 30 degrees. Say pi over 6 is here, mona. Pi over 6. What type of a triangle are we going to have? Mona ilore itlo ba 90. Ilore mona re na le pi over 3. Okay. Ilore for this side our ratio ke mona ke 2 as we would have our circumference. Our reference triangle. Okay. Mona le 90 degrees. Okay, so mona le 90 degrees and pi over 3 ke 1. 90 degrees and pi over 3 ke 1. And this side is square root 3. So we want to label this part here, the coordinates here. What are the coordinates? What's your guess? I'll give you a minute to try and figure it out. Okay, now coming back here, re hopole ha hore mona mo go ngozeng ka bokhubedu re kile go draw this reference triangle here. But remember that the actual hypotenuse on the unit circle ke bokae? Ke 1, right? So we are going to now try and find the actual base here. Let's call it the base. The actual base in has a square root 3. This is the ratio, reference triangle, but we need to find the actual lengths, base and height and hypotenuse in the unit circle. So just by conversion, a hypotenuse usually in 2 in the reference triangle ke 1. This means side how 1 in the reference triangle over half. We can quickly do the cross multiplication here. 1 times 1 divided by 2 atola half. And then the side ailing square root 3 itlo. How do you find it? This times this divided by this, we get this. So these are the actual sides inside the unit circle. So ke tlo di bongola ka botso he ka monana. So it's a square root 3 is selling k square root 3 over 2. That's the actual length inside the unit circle, and the 1 king k half. Okay, now what are the coordinates here? Coordinates tsa mona king the x value is square root 3 over 2. The y value is half. So what does this tell you? How the coordinates? This tells you, okay, the cosine of pi over 6 is square root 3 over 2. Okay? And the sine of pi over 6 is 1 over 2. Okay, let us try and do another one. Okay, I'll turn the page. I'll draw a new diagram. But with reference to the unit circle, pi over 4 is 45 degrees sharp. Let's try it. Okay, so we have 45 degree triangle inside the unit circle. So what we know as square root 2 is hypotenuse. Come on, I say radius is 1. So our square root 2 is now 1, meaning that our side in a ailing 1 mona is a 1 over square root 2, and the same applies to the other one. Now 1 over square root 2 usually it closer square root is a closer class. So to remove the square root, you multiply by square root 2 over square root 2, this is equivalent to 1. It's calculator ka 1, but this is going to manipulate this such that it's the 1 times square root 2 is square root 2, and then square root 2 times square root 2 ibang 2. Okay, so o tla fumana hangata e ngotswe tjena in a lot of textbooks. All right, so this means that on our unit circle, going back here, on our unit circle have a 45 degrees this moon coordinates is telling here mona is 1, and 1 is now square root 2 over 2 using the conversion. So the coordinates mona and extend this line, but these are the coordinates of this here, just extension so that we don't get confused here. Let me write the coordinates using a black pen. So for the x value, distance from here to here, the originally is 1, but in a unit circle, square root 2 over 2, even square root 2 over 2, as we have done here. Right, and then another one. Originally, this side would be 1, but it's in a unit circle. Now this one given 1, and we converted it over 1 over square root 2, but now we want to write it as comma square root 2 over 2, right? Now we are going to add our last angle, reference angle mona, 60 degrees, right? 60 degrees, what are the coordinates on the unit circle? I'm going to nicely extend this here. Okay, now going back to the unit circle, get more like 45 degrees. Say your 60 is here for argument's sake. So your 60 is here, and you know originally if you have a 60 here, this means you have a 30 there, and you have pi over 2 here, right? So how are your sides? Originally this side would be your 2, and this would be your 1, and this would be your square root 3. This side is written in red. The ratio the reference triangle originally, but now we want to convert the ratios to the length, the actual length inside a unit circle, and still conversion yani cross multiplication. So in a 2 originally 2, now in the unit circle 1. Now we want to know na 1 yona ke bokae. All right, so 2 is 1 yona ke bokae. 1 times 1 divided by 2 ke half. However, mona is 1, then mona rena le half. Okay, so however mona rena le square root 3, so rena le bokae in a unit circle, right? So it's about this times this divided by this, we have square root 3 over 2 mona ke the actual one inside the unit circle ke square root 3 over 2. Well, what are the coordinates here? The x value ke half, and the y value corresponds the height ke that corresponds here. It square root 3 over 2. Right. So okay, let me write it here. Here is 1 over 2 comma square root 3 over 2. So le ena ha se le tjena wa tseba gore mona ke 30 degrees, 45 degrees, 60 degrees, and this says to you that the cosine of 60 kappa the cosine of pi over 3 ke half, but the sine is square root 3 over 2. Really, how to the coordinates, you will easily be able to evaluate your angles, right? So you can pause and look at it. So we first did this coordinates. Usually, for this ones, you are going to use the cast rule and the cast rule, and now evaluate this ones. Remember, cast rule area. All are positive here. Okay, sine is positive here. Tangent is positive here. Cosine is positive here. So remember. Or hopefully how it's the conversions in. But what I would like to emphasize, when you know these coordinates, when you know all these coordinates, it's easy for you to know these ones. How did you work out, fella? Using this, you can evaluate the reference angles. I mean the cosine and sine of the reference angles, as well as the tangent, of course. I get it. Thank you.